Then let's get started. Welcome to the review meeting for 1.127. We start with Radoslav and the OpenTelemetryCollector feature gate. Next up is Dimitar with the internal DNS secret configuration and the seed API. And finally, we have Marco with the mutating admission policies for everyday operations. All right, with that, Radoslav, please get started with the first topic.
Thank you, Rafael. I hope you can see my screen. You can see me. You can hear me, right? Okay.
Yes.
Thank you. So today, I want to show you the progress on GEP34. All the progress that has been done so far is hidden behind the OpenTelemetry feature gate. As a reminder, what GEP34 is. GEP34 is a part of the Observability 2.0 initiative in Gartner. And what the Observability 2.0 is, the TODR of it is, basically we're trying to integrate OpenTelemetry components, OpenTelemetry standards inside the whole observability setup that we have in Gartner. The hope is that Observability 2.0 will create a very nice scaffold for everything that's to come in observability in Gartner. Now, what OpenTelemetry is, I'll talk about that in a moment. I'll remind everyone what basically is happening with OpenTelemetry. Focusing on GEP34. GEP34 is just a part of Observability 2.0, and it focuses on mainly on how we collect logs from our shoot clusters. I've linked in the chat the Observability 2.0 document, GEP34, and some implementation details if someone wants to take a look at them for more information. Now, before I talk about what GEP34 actually achieved, I'd like to give you a quick rundown on how collecting logs from shoots looks like in Gartner currently. Very simple, simplified image of our current setup is the one you're seeing right now. So basically, on every shoot node, we have a validtail component. That validtail component knows how to scrape logs from pods and knows how to scrape logs from the system components via Azure Node. And then using the Loki API, it sends those logs to the Vali that's in the shoot control plane. Now, why the Loki API? Well, as a reminder, Vali is actually just a relatively old fork of Grafana Loki. And validtail is actually a fork of Promptail. So both of them, they know how to talk the Loki API. And there's a bit of issues with this setup. One is that it's very opinionated. What I mean by that is the backend is always the Vali in the control plane. That's non-negotiable. The log shipper is validtail, and validtail talks only Loki. So if you want a persistence layer, well, it has to be something that talks Loki. And we're using Vali. Now, since Vali is quite an old fork of Woki, we'd like to update that. And Observability 2.0 achieves this. Now, how does it achieve it? First, we have to talk about OpenTelemetry. Now, what's OpenTelemetry? A quick reminder. Basically, in the observability world, there are a lot of standards. How are logs structured? Everyone has their own solution. We have Elasticsearch, we have Prometheus for metrics, we have the Grafana projects. Everyone doesn't agree with anyone. OpenTelemetry has OpenTelemetry tries to achieve a standardization of observability topics. So how do we structure our logs? So what's the data format? That's the standardization part. OpenTelemetry provides tools and instrumentation how to integrate with the OpenTelemetry formats, and it provides a very important component called the collector. So the collector has one important feature. It decouples the let's say, signal collecting components from the signal aggregating or storing components. This decoupling lets us use any log shipper or metric collector with any storage on the other side. And that's very powerful. Some more information about the OpenTelemetryCollector, since I think it's a very interesting part of the whole implementation. It's basically just fan in, fan out program. It knows how to speak different formats, and it knows how to output different formats. This is the actual picture that OpenTelemetry provides in their documentation. They have these things called receivers and these things called exporters. I like this image more since it's more compressed and easier to see. It basically knows how to talk different input formats, knows how to talk different output formats. So we can have low-key input format and Splunk output format, for example. And in the center here, there are some processors, connectors. Those are just things that know how to transform the data that has been collected from one side, apply some transformations to it, and then output with additional labels, for example, with some labels removed, some filtering and things like that. And this here is an example of the auto binary format for logs. There's a format for traces, there's a format for metrics. I'm showing you just the format for logs right now. Interesting parts here are the attributes. Those are just sets of keys, values, resources. This is basically a description of where we get this signal. For example, this is service name, donut shop, for this Kubernetes service. We have a Kubernetes spot UID. Now, one important part that I missed on talking about a moment ago is OpenTelemetry also defines some semantic conventions. So, for example, here we can see one semantic convention, which is the label Kubernetes spot UID always has the same meaning, no matter what the context is. And that's very powerful since two systems that know nothing about each other can freely share signals with each other if they follow the same semantic conventions. And integrating OpenTelemetry into Gartner has a lot of benefits. As I've listed here, there's the industry momentum, so we can leverage this momentum to easily integrate with other components. We have a unified data model, that's the binary format I talked about a second ago, and we have vendor freedom. So we can always choose our persistence layer. Not only us, but stakeholders and shoot owners can freely choose their own vendor, choose what persistence layer they're using. And there are a lot of more benefits. And again, please do check out the Observability 2.0 document if you want more information. And now let me show you, now that I've talked about the collector, what GEP34 achieves. So a reminder how it looked before GEP34. We had a Valley tail on shoot nodes, and we have Valley in the control plane, and they're talking the low-key API. Now, the changes in GEP34 are the Valley tail has been replaced with a collector, since the collector has a lot of different receivers that can use. It uses some file scraping receiver, journal D receiver, so that enables it to achieve a feature parity with Valley tail and be able to collect basically the same signals. And then via OTLP, so this format right here that I talked about, via OTLP, it now sends it to a collector in the control plane. This collector then, using a low-key exporter, sends the signals to the Valley in our control plane. And now, when we have this collector in the control plane, one thing that we can easily achieve is replacing Valley. It's basically just stop deploying Valley in our control planes, start deploying something else, and then configure the collector to just output the format that the new persistence layer will be using. Also, in the future, we'll be able to give shoot owners the ability to choose where these signals will be going. So for example, that could be done through a configuration, or the idea for now is through an extension. They can choose, well, I want this collector here to actually send the signals to my persistence layer. Here's the endpoint for it, and I want it to be Victoriavox, for example. Yes, more information on that on Observability 2.0 document. Now that I've talked about what the new setup is, demo is really quick, really simple. I've started a shoot in my local setup. Here we can see the shoot. One thing that I missed talking about, since I don't think it's very interesting, is if we see in the garden namespace, for the seed in the local setup, we can see that now we have a OpenTelemetry operator. I don't think that's very interesting. It's just our operator that we'll be using for deploying the collectors right here. So using it, we can see that in the shoot here, we have an instance, a deployment of OpenTelemetryCollector. It basically does this via a new CRD that has been installed called OpenTelemetryCollector, so OpenTelemetry.io. The other interesting thing is that here, the lower terminal is I've execed into the shoot machine, and we can see that there's no longer Valitail. There's currently an instance of the OpenTelemetryCollector service. And now looking at the Plutono, everything is still the same. We have our pod names, we can choose our origin for the shoot system, for example. We can see the Calico node works, and feature parity is basically achieved. So from the operator side point, there aren't many differences. Maybe a couple of differences could be additional labels, or some labels will be renamed, but the change shouldn't be anything drastic. One final thing that I'd like to show you is just a second. Here, this is an interesting visualization of how the collector actually looks like. There are these things called pipelines. This is basically these things are right here. So this is one pipeline. This could be another pipeline. For example, this could be another pipeline. So in the collector, we define our own pipelines, and this is the collector in the actual shoot node. It has two pipelines, a journal pipeline. So basically, journal collecting walks through journal and collecting walks from the pods via the firewalk receiver, and then it does some transformations on the signals, and then it outputs it via OTOP. So this is this part right here to the collector in the control plane. And the configuration is, I'd say, very readable and at least easier to work with in my experience than the Valitail config that we had so far. And that's it. Thank you. If there are any questions, I'm all ears.
Just one question.
Very nice.
Mm-hmm.
Yeah, go ahead.
You mentioned that you will allow the end users to configure it to their collector or exporter, right?
Yeah,
So that will be an additional option, that the control plane logs are there with the control plane in Gardener seed as well as being replicated elsewhere, or it's a choice that they just move these logs from us to their own exported.
Well, no. So one use case could be, I might be misremembering, but I think it was Stack IT, since they're deploying their own Gardener landscapes. They want to collect their signals in a single place. So that's one use case. But another use case could be shoot owners sending signals, not control plane signals, but some other types of signals through this extension. Okay. But that's still a work in progress. Important part is that scaffolding will be created for that, and a lot of things could be achieved when we integrate OpenTelemetry into observability of Gartner. Yes, Johannes?
Yeah, so it looks very nice. It's a great progress and helps us probably get rid of Wali soon. Is it necessary to have this stuttering name like OpenTelemetryCollector in the control plane, or can we get rid of those? It looks a little bit funny.
Yeah, it does look funny. Well, sadly, there's currently no way to do that. OpenTelemetry as a project is still maturing, I'd say. Progress is very fast. There's a lot of people working on it, and there's a lot of interest. As I said, it's being adopted by almost everyone, at least every big current observability solution is integrating OpenTelemetry. So a lot of work will be done there. But currently, sadly, the operator deploys the collector. Basically, the name is hard-coded. That's what I'm trying to say. But we're thinking on giving some upstream providing some upstream changes so that the names can be chosen through the CRDs.
Okay, sounds good.
Yes, Jan? Sorry, maybe you clicked on raise Jan.
Can you hear me now?
By mistake? Yeah. Okay, so
yeah,
it was
sorry.
a mistake.
Yeah, double mute. So first of all, thank you very much for the presentation. Very insightful. I just want to clarify a little bit. So if I understood correctly, the collector is available to the user for user-driven ingestion, correct?
User-driven ingestion, you mean, could you explain what you mean by user-driven ingestion?
Like some user of Gartner can basically collect his own data and basically can then extract them out over to OpenTelemetry of his own. Like, is that correct if I understood this? Not sure.
So that topic specifically is something that hasn't been discussed very deeply still. That's something absolutely that can be achieved, but whether we want to do that right as of now is it's not sure. For now, all the logs that are being collected are the Gartner specific logs from the system components that Gartner deploys and from the pods that Gartner deploys in the kubesystem namespace. But changes will be pending.
Okay, thank you very much. Just was curious about that.
All right, thank you for the questions.
Okay. Yeah, thanks a lot. Great. Then let's move over to the next topic, which will be presented by Dimitar, and it's the internal DNS secret configuration.
Okay. Hello, everyone, from my side. Today, I will present this rather small change in terms of what it actually does. This is basically regarding internal DNS setting for the seeds. I will talk about what was the current state and what changed with this pull request and what are the benefits of it. So straight to the terminal. Okay, what was the old state previously? As you may know, internal domain settings were configured globally per landscape with secret that looks like this. So basically, we have a secret here. The secret data is omitted, but in order for Gardenlets to understand how to handle DNS and domains for shoots, they were issuing a query to the Garden cluster, basically selecting secrets that have this row internal domain label, and then from the annotations they were extracting some kind of data. In this case, what is the provider for the DNS, and also what domain they should use. So this was a global per landscape configuration. What was proposed was a new API which looks like this. So basically the same information is incorporated in the seed spec. As you can see here under DNS, we have this internal right now where we specify the type of the provider, the domain. We have an optional zone, and here we reference credentials. And for now, this can only be secret, as it is the case today. But later on, here we will add support also for workload identity, which is another topic in the realm of security and Gardener. So what are the pros of this approach? So we split the configuration across seeds. You can still have a single secret that that handles all domains. But now, if you want to, you can configure seeds to have different internal domains, which translates to reduce blast radius in case some secret leaks, for example. We also are introducing explicit configuration here, which makes it easier to validate, less error prone. Also, something that is not achieved right now, this secret here is only validated that it has certain annotation and labels, but then provider extensions do not actually validate the secret contents in terms of what is provided there. And this is a low risk because usually these kind of secrets are provided directly by operators, but still it is error prone. Okay, so as I already said, it will allow a different type of credentials to be referenced here. We also reduce the risk of rate limits in case the external DNS provider imposes such based on credentials. Okay, so with that, I'll give you a short demo of what this means for you and for operators. On the left-hand side, I have deployed a local gardener. So first, I want to show you the gardenlet configuration. As you can see in the gardenlet configuration, we have this seed config, I think it was called, yes. And in that seed config, we basically have the seed specification, and in it we have this DNS setting, which only contains provider, but as you may already see, it does not contain this internal config. And this is the case if you do not configure it explicitly. But if we go and check out the seed spec, we can see that the settings are already there. And why is that? This is because on startup, Gardenlet will fetch the global secret that is currently configured for the landscape and will update its own seed to include this information in the specification. This would mean that operators would have to amend their seed configs in the Gardenlet configuration or seed templates include this explicitly. After release of Gardener 1.122, this would become a required field. So operators should take action and migrate this and set the settings in the seed config explicitly. One more thing that I wanted to show is that if we go and check the current internal domain secret, we can go ahead, once we migrate the seed config explicitly, we can go ahead and remove this label. After removing it, I can still go ahead and apply a shoot spec. And this is going to be created successfully. Okay, so what is next? Yeah, as I said, right now, extension providers do not validate the secrets that are used for internal and default domains, but this is going to change once we start maintaining differentiating labels on such credentials, secrets, and workload identities. As I already said, the field will become mandatory after the 1.129 release. So take the time and migrate your seed configuration. You can find pretty descriptive release note in the Gardener release, so you can follow up on that. And one last thing, we want to introduce the same API changes for the default domain configurations. I already have an issue and even a draft pull request opened. So if you want to share any feedback or express any concerns, feel free to comment on that. And with that, I'm done, and I open for questions and comments if there are any.
Seems not for now. All right. Then thanks for presenting this, Dimitar. And over to Marco for the mutating admission policies for the everyday ops.
Yeah, thanks. Right, let me share my screen. And then before we get into the code, I have some slides. All right, mutating admission policies. Everyday operations, that seems to be like currently my second name. What does this mean? Yeah, for like if you're not an operator of a landscape, then this, like one of those things will happen to you pretty much every day. Somebody comes in, there's a situation or like an incident or whatever, and you just need to do a quick one-off change to an already running cluster to some resources. And that most of the time means you want to like remove, add, or change like a property in some spec, or like, for example, an argument for a container. You might want to delete complete resources or whatever. And the most important bit is, while Kubernetes is great and always ensures that everything reconciles back to the desired state, this is specifically what you don't want to do in this case, right? You want this to be like a one-off modification that sticks. And what people usually do is they do some webhook-based approach in order to like keep the change as is. We also did this in the past with a few iterations there. You can use the OpenPolicy agent, but that one uses the Rego query language. And if you're not an old school data log programmer, then this doesn't come very easy and very testable. Then there's Kyverno, that is the solution that most people seem to be using. And here the problem is Kyverno is like quite a beast. It's very complex. It consists of many, many different components. We've seen issues where, for example, stakeholders deploy this themselves and then misconfigure it in some way such that it might even bring down your entire control plane. It brings like a gazillion of CRDs and lots of dependencies. So if you like do it right, you are even bringing a Postgres database for like reports and stuff. So that's also not something we wanted to use in that case. You can do lots of custom stuff, like implement your own solutions, or you can use the solution I'm going to present today, that is mutating admission policies. And what is this? Why is this thing in the way? I don't know. So what is this? You might have heard of validating admission policies, and this is pretty much the big sister of that feature. The overall idea is very much the same. You can have webhook-like logic without the need of a separate pod hosting the webhook. So it runs in process in the Kubernetes API server. And validating admission policies can replace validating webhooks, and they are GA since Kubernetes 130 already. And mutating admission policies can replace mutating webhooks. This feature is alpha since Kubernetes 132, and it recently was graduated to beta in 134. Those policies rely on the CEL language, which you might have seen already. Like Google has been pushing this a bit. It's also like has its own very limited set of expressions, and one of the main qualities of this expression language is that you can look at an expression and evaluate how costly it is. And this is specifically important now that this stuff runs inside the Kubernetes API server, because it means you could create queries which are simply too costly for the API server to evaluate in process, and then your expression will be rejected. The policies allow you to express the modifications you want to do or the validations in two different kinds of syntaxes. One is the one that you already know and love from the webhooks, which is JSON patch, but it also allows a more concise syntax, which then ends apply configuration, which just basically uses CEL-like expressions. And now that you know that you can have pretty much two things which are meant to achieve the same goal, like let's say mutating admission policies and mutating admission webhooks, the question is which runs first? And the answer is policies run before their webhook counterparts. So first the stuff is processed inside the API server, and then there might be calls to still existing webhooks. All right, and now let's take a quick look at the involved resources there. So we have three kinds of resources. One of them is optional. That's why I dotted the lines here. One is the actual mutating admission policy. And this is basically an abstract definition of the mutation you want to do. Ensure this label has that value. And then you have an optional parameter resource, which could be a config map or like a custom resource. You can pretty much roll your own stuff there. or you can just not use parameters and hard code everything in the policy. But you can use it to provide the values for like the label name and the actually desired value. And then you have a binding which connects a policy to the configuration and defines some matching criteria, like which objects should this match on. Label selectors, object selectors, whatever. So much for the theory. Now let's take a look at an example. So here I have the 3 objects open I talked about. I have a mutating admission policy that has the goal to look at a deployment and look at the command array of a container. And what this wants to do is take a specific command and then set a specific value to it. One example where you could use this for is I have a local environment right here, and I have a shoot already in place. So one of the things we do quite often is to increase the log level, for example, of the component, right? So for the cube scheduler, for example, you can see it has a verbosity configured to 2. And now if you just want to go in and increase the log level on this, you could use a policy like this. Here's a bunch of stuff like that it matches deployments, and it is a webhook-like thing. So it watches, creates, and updates, for example, because you don't want to have this reconciled back. And in the end, this will create a JSON patch. And it's a list of patches. So it's 2 patches executed in sequence here. And the outcome is pretty straightforward. So it looks at the spec template for a specific container. And one of the things this policy needs to do is like figure out up top which container. Then it looks at the command, and then it wants to find out like what's the index of my command that I want to modify. And this consists of 2 things, because this command, this parameter may or may not exist yet. So there's an optional remove patch here, and then an add with the actual value that gets provided. This looks a bit complicated, and it would be nice if it would be much easier and you hadn't have to use JSON patch, but could instead use the apply configuration. But apply configuration is works best, or works pretty much only nicely if you're like adding things, like injecting an additional sidecar, adding a label, or these kind of things. And in most cases, you will have to default to JSON patch. And up here is a bunch of definitions going on where it tries to figure out like what's the index of the actual container, what's the index of the actual argument, does it even exist? And if so, does it have the value that I'm expecting, and so on. And then optionally does 1 or 2 patches to it. The binding, as I said, is pretty simple. So it defines like a matcher. Here we only want to match namespaces that have a very specific label. You could also pick only resources that have specific labels or whatever. And here's the config map that says, okay, the name of the deployment is kubescheduler. The container inside there is also kubescheduler. The argument is -v, and I want it to have like a value of 4. And if you now apply like all of these resources, then we can still see that the namespace does not contain the label yet, which means if we go in and and patch the deployment. Then this still means that, wait, what? Oh, sorry, what am I doing wrong? Oh, it's wrong. Oh, yeah. Okay, so here you're seeing why this feature is still in alpha state. This is an issue that has been raised upstream as well. From time to time, it may happen that although it seems you applied all the resources correctly, that the parameter, the config map I defined, is not found. And I configured the policy and the binding to deny the resource if the parameter isn't found. So in this case, this is what we are seeing. In theory, this should be working. In practice, it doesn't. Okay, let's retry this one more time. And then hopefully that will work. Yeah, or it doesn't. Nice. Okay. Yeah, sorry about this. We've also seen this, and most of the time, like it works on second try. What you should have been seeing is that once we label the namespace correctly, then the kube scheduler actually gets the kube scheduler pod gets recreated with the correct parameter. One of the things that they need to fix is like this very specific issue. I can also put it in the additional notes for this on the presentation, and then we can follow up on that this actually gets resolved. Yeah, so most of the time this has been working well for us. We have been using it for a while for some use cases already. And it has graduated to beta in 1.34. This also brought additional metrics in which allow you to see like which of those mutations have been applied successfully and which of them haven't, and so on. All of these things are still not there in the 1.32 and 33 Kubernetes versions. All right, unfortunately, this is demo live, so that's it. All I got. Thanks.
Marco,
Yeah.
one question from my side. I mean, you noted it looks complicated. I think it might actually be complicated. So therefore, the question is a little bit, do we plan to kind of create some simple scripts for common problems that operators can use either, or is that something that each operator has to maintain for themselves because kind of the problems are always different?
Yeah, so like all of the stuff I wrote here is like internally available for us. So like for us, we have this repository with a number or handful of common issues. I think now that you can easily separate the abstract modification you want to do from the actual configuration, I think we could easily move many of those to an open source repository. It doesn't need to contain any specifics to like our landscape or whatever. So yeah, we could easily move it to someplace open source. I think that's a good point.
So I don't know what place that would be, but I think, for example, in most Gardener repositories, we have these example folders where we have actually some examples of our resources or what you can do. And I think for operations, those kind of things would actually make a lot of sense. But as I said, I'm not sure where it actually fits in best. Maybe we have to take a closer look there.
Yeah, we can find a place for sure.
Otherwise, it was very interesting presentation. Thank you.
Yeah, thanks. More questions, Toby?
Yeah, also, first of all, thank you for introducing the topic. I was wondering if you may be aware of a tool that can convert, like, for example, Kyverno policies, mutating policies to something like that, or is it something we have to do in manual labor?
So for many things, I mean, you can use JSON patch here, right? So for many things that create you a JSON patch, you can like more or less just use it. Kyverno, well, contains its own magic of converting CRD-based stuff into the actual webhook things. So it's not quite easy, I think. Basically, you would need to run pretty much the same stuff that Kyverno does internally, right? So I'm not aware of a tool that actually exists. I'm not even sure if Kyverno might store the actual result somewhere, to only update it if you update the CRD, which would make sense, right? That it compiles it to some state. So yeah, sorry, I'm not aware of anything that helps you.
It's just was curious. Thank you very much, anyways.
Yeah. Victor.
Yeah, so multiple points. First one is a question. All of this seems to make sense only for control plane resources that are not managed by GRM, right? Because for resources that are managed by GRM, they will be overwritten, right?
So the point is, they shouldn't be, right? So we've been also using webhook-based approaches in the past, also for resources managed by GRM. And this whole thing should still work, right?
Yeah, it works, but I mean, for example, for it to work with the GRM, you have to annotate the managed resource to be ignored, right? And then, because otherwise, I think GRM will reconcile it back after the change from the mutating admission policy.
Yeah, so in some intervals, or like on update of the original resource, it will try to reconcile it back. But then on update of the resource, still your mutation webhook will be applied, right? So GRM will still try to do work, and it's unnecessary work, but you don't necessarily have to apply the ignore annotation blocking like actual reconciliation and stuff.
Okay, so next question. Have you researched if it's like compared to, it seems the mutating admission policy uses this expression language, that it's kind of a subset of all the things you could do with the mutating webhook. For me, it makes sense logically that this to be quicker, because this will be calculated in the CAPI process, and standard webhook is like, for it to work, there is network traffic and so on, so on.
Right.
Does it make sense? That's if you could use mutating admission policy, it's better to use it performance-wise and so on.
Yes, I think this is one of the arguments. Also for the validating stuff, right? People are moving many things to validating admission policies specifically for that reason. That for many validations, it doesn't make much sense to do like an additional back and forth network call and so on and so on. So it's much faster to do it in process. Yeah. And I think for the mutation stuff, it's pretty much the same story.
Okay. And there is the guarantee for like it takes like a finite amount of time, because mutating or validating webhook could theoretically take whatever time it wants.
Yeah, right. So I think the original documentation has some hints on the cost calculation stuff. They might only have the links in the validating admission policy. But yeah, some links in the documentation are like how the cost for the CL stuff is calculated and how rejection works and so on. So yeah.
Okay, thank you. Those are my points.
Mm-hmm.
Thank you for the presentation.
And we have Ashwani.
Yeah, hi Marco. Thanks for doing this. I'm the beneficiary. So we had this. Can you have two policies on the same object, and then what happens? I mean, can that lead to a problem, or like one adds and one removes? And do you trace it? If can you see it in the logs or somewhere? What bring in this change if you have these policies defined?
So in 132, you don't really have good observability of what actually happens. You know? So in 134, they added a bunch of metrics where you can try to understand that there are policies modifying certain kinds of objects and which they are and how long they take and if they are rejected or successful and so on. In 132, it's basically up to you.
Okay.
And I think similar to how mutating webhooks work, nobody prevents you from creating like an endless loop of webhooks with policy of re-invocation policy if necessary, modifying the same object and then like looping through the whole thing, right? So I don't think there's a like an actual safety mechanism in place there.
Okay, thanks.
All right, then I guess that's it. A lot of questions today. Nice to see.
Great, thanks.
Thanks, Marco. With that, we are at the end for today. Thanks to all presenters. Thanks everybody for joining, and see you again in 2 weeks. Have a good time.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye-bye.
Bye-bye.
Thanks, bye.
Bye.